Can everybody hear me now?
Yes, we can, Theko.
Yes, okay. I see I am on stage with Fred. Fred, thank you very much. It is 1 minute past 2 o'clock on my side. So yes, let's start the 2021 COMOS conference, first of its kind. The theme this year, or the first year's theme, is COMOS and the digital twin. Just some housekeeping rules. There is a maximum of 4 people that will be allowed on stage. The presenter will be on stage. And then once they've presented, they will leave the stage, but they'll still be able to hear the sessions. There is a chat button. One of the chat buttons, there are two. There is a generic chat session that is used for everybody on the platform, everybody in the conference to ask questions. Then there will be a separate admin chat for the presenters just to sort of exchange information if there's a need for. Welcome everybody. Those are the housekeeping rules. I am going to give over to Fred, the sponsor for the conference, just for the welcome speech and just to sort of have a brief introduction to everybody. Fred, over to you.
Thank you, Theko. Thank you very much, and welcome to everybody. It's quite a unique experience doing it on this basis, certainly a first for me. When the request came to participate in this conference, I was quite excited and felt rejuvenated. You know, with a personal experience base that spans from the early 1990s, where we explored, experimented, and implemented database designs and upgrades for the process environment with software such as PySys, yes, someone might remember that, later Dessoft, and then also SmartPlant in its various iterations, InTools, and today COMOS. It completes, for me anyhow, the development cycle as we hoped it would be. In parallel with that, we also dabbled in the 3D environment, Solid Edge et al., where we migrated from a physical scale model built by modelers to this computer-generated 3D model with engineers sitting in front of their very high-level computers. We now had a model where we could virtually walk through and could see how the end product would look like. It also helped us to coordinate and integrate the various engineering disciplines to deliver a final operational process plant. Also, in parallel with that, we had a progression of hard copy data storage systems where we deposited drawings and documents in an as-built status for record and operational purposes. And some of you might remember Domino.doc, TDMS, and later, and now ProjectWise, to where we now are really operating in this cloud-based data storage systems, which is accessible from anywhere with the appropriate user protocol. My apologies for that. We also let me just get my price back. We also saw the ongoing development in process design and process automation and subsequent plant control system upgrades. It goes without saying that ongoing software development and applications were only possible because of the ongoing hardware evolution. You know, if we look back at where we came from to where we are today, one can only imagine what the future holds. It's exciting, to say the least. My personal experience in the mineral beneficiation and pyrometallurgical process environments for both ferrochrome and PGM covered all aspects of design and engineering from concept through to final build and operate. I've also seen the desperate need for operations to have all the tools and records available once a process plant becomes operational. By the same token, I've also seen containers full of asphalt documentation being dumped because the task of maintaining such, and I'll call them libraries, just became too onerous. However, with the advent of cloud information management specifically became much more convenient and therefore usable. The challenge to maintain and update such information still remains, and that is a subject on its own. However, moving from updating and redlining PNIDs, IO dumps from the PLCs and control system, etc., to fully fledged process engineering database has been a major accomplishment. It still requires a concerted effort to keep it up to date, but implementing plant process changes and plant upgrades are now much more manageable. Being able to interrogate a plant interruption from a SCADA via an engineering interface virtually into the 3D model environment gives ops and maintenance teams a much improved environment to keep process plants optimal. And having the digital twin takes it a step further, where we can virtually validate process performance prior to it being built. I am certainly not an expert in any of the topics that will be presented today, but suffice to say that I've participated in pilot projects and different software applications for the last 40-odd years to such an extent that I can with confidence state that the subject matter today presented is suitable, usable, manageable, and maintainable. And we have sufficient reference sites around the world as evidence. Therefore, it's a privilege for me to welcome all the attendees and speakers to this unique event. And for me, as I said initially, it's certainly a first in this unique virtual environment. I can safely say that it would be difficult to find more suitable speakers than what we have today. They truly represent a comprehensive spread of knowledge and experience from concept to implementation in both the developer and user environments. I'm looking forward to how Letsie, who's the Customer Experience and Marketing Coordinator at FrequencyShift, will introduce us to the COMOS and Digital Twin. Now, he's part of this new generation, bubbling with enthusiasm, and it bodes well for our future to have such enthusiasm and passion for the subject matter. But then also, I want to thank each of the speakers that are presented today for agreeing to participate and share their knowledge and experience on the subject matter. I'm confident that they are subject matter experts, and they will cover the spectrum from software development, user interface to full implementation, inclusive of the operation environment to its fullest extent. Thank you.
Thank you very much, Fred, for your kind words. And yes, indeed, we have come a long way as an industry. Yeah, just to introduce the program, we will have Marc presenting from Anglo's point of view. So Marc has got over 30 years experience in the industry, and he is a lead instrumentation engineer for Anglo. Of course, we have Frank. Frank, who is our global partner manager with over 20 years experience representing Siemens. We do have Chrisna as well from PwC, obviously quite experienced in the sector with over 20 years experience in the mining industry. It wouldn't be possible without EDM, who are the custodian of commerce within the South African market. Reimer, welcome as well. From the EPC's point of view, of course, we have Gebbie, a well-experienced individual with over 27 years experience in the process control across different industries, and is currently the Vice President of Electrical and Control Instrumentation at DRA. Of course, we've had Fred. And myself, I am the Head of Commerce Implementation at FrequencyShift. So yes, That is the speakers that we have. The program today, we're going to start with, let's just have a look here. So the next person up would be Marc Francois. That will be followed by Gebbie. And then I will come in on the third session. And then Chrisna will come towards the end. Reimer will come in just before Siemens. And then we will have Frank presenting right at the end. For the sake of time, so we are going to use the chat for capturing all the questions. So all our audiences, please make use of the chat functionality to sort of post your questions. And then right at the end, we are going to have about a 30-minute Q&A session where all the answers will be put together and be answered. Marc, thank you very much for your time. Yes, the stage is all yours.
Thank you, Theko, and thank you, Fred, for the introduction. I appreciate it. My name is Marc Francois. I'm a lead instrumentation engineer working for Anglo Platinum. For those that don't know, Anglo Platinum is a mining company which mines platinum group metals. We have operations in South Africa, and we also have one operation in Zimbabwe. As I say, I'm responsible for CNR projects within Anglo Platinum. That includes, from feasibility study, design, testing, implementation, right up to optimization. That also includes the CNR portion of larger projects, greenfield projects, and that as well. So what I'm going to take you through is sort of my personal experience with COMOS, or why we implemented COMOS within Anglo Platinum. So I'll start off, why we looked at COMOS in the first place, the COMOS journey to date within Anglo Platinum, and then some of the challenges and benefits we've seen using the actual product, and what we plan to do with COMOS in the future. Why did we need COMOS, and why did we look for an integrated platform? I think as Fred alluded earlier, information specific in the project environment was stored in various packages. Some of it, a lot of it, we all engineers, was in Excel. Most of our drawings was done in AutoCAD. Some network drawings and that were done in Visio. We had some process description, functional specifications done in Word. We used a product called InTools for instrumentation data. And there was little integration between these various packages and between the disciplines on the project. So there was a lot of duplications, errors kept creeping in. We spent many hours verifying data between the various disciplines, making sure that if piping changes were made, the appropriate instrumentation was changed, and that all took time. And then, information wasn't always consistent. Like I said before, change would be made in the process world, which wasn't filtered down to the instrumentation and was only found out later, which obviously cost time and money. It was also difficult to extract data. What we used to do in the past, as Fred said, we would, once a project was finished, we'd convert all the AutoCAD drawings and Visio drawings and Excel spreadsheets into PDFs and load them into a document management system. And often these PDFs are not searchable, so to find the latest drawing or the specific information you're looking for takes time. We also used to store it per project, so unless you worked on the project or knew which project covered a certain section of plant, it was very difficult to find the latest as-built drawings. In fact, we've often put project data into our document management system, and then the project wasn't implemented for whatever reason, and the documents are then in the document management system and used as built drawings. And then one of my biggest problems and one of the biggest concerns is that once a project is finished, nobody ever updates the documentation again. changes are made on site, minor changes, major changes, and the documentation is not updated. So when we want to start a new project on the sites, we spend a lot of money going to make sure that the latest document is as built, and that obviously wastes time and money. So we were looking at an integrated package that we could better manage all of these issues, and all of our sites use the Siemens PCS7 control system, except our precious metal refinery. But so COMOS was probably an obvious choice and a good fit for what we were looking for. Sorry, I'm go to the next slide. Okay, so our first implementation was at our base metal refinery. It coincided with a control system replacement at our base metal refinery. We had an old Apex system that was actually brought out by Siemens, and the natural migration path from Apex was to PCS, Siemens PCS7. So we started implementing COMOS there for that project, but that was just limited to control information, instrumentation information. So we did PFDs, PNRDs, loop drawings in COMOS for that project. And it was actually a direct result of an incident that happened at the base metal refinery. We had a fatality there, which was caused by incorrect documentation. So there was a big drive to get the documentation up to date, and that's when we started implementing COMOS at our base metal refinery. Since then, we've done a number of projects in Anglo Platinum on COMOS. Our Mogalakwena South concentrator had a very similar exercise where we migrated the Rockwell system to Siemens, and at the same time we used COMOS for the instrumentation and PNRDs and PFDs. Polokwane smelter, there's a SO2 abatement project that was done in COMOS. Unki smelter was done in COMOS, which was a greenfield project. Waterfall smelter, we're currently building a new slag cleaning furnace that's being done in COMOS. ACP, there's quite a lot of optimization and upgrades being done at ACP, and all the PNRDs and data is being converted to COMOS. Mogalakwena North, we just completed converting all the PNRDs into COMOS. And then we've got a small plant, a test plant that we're also doing in COMOS at the moment. Okay, as I said before, the first implementation was just limited to piping, IO list, instrument data, etc. In the later projects, we started implementing electrical information, motor list, single line diagrams, MCC bucket drawings, etc. And on the later projects, we started actually including some of the piping information as well. This is just a graphic picture of where we are at what we look at, going into the future. I'm sure some of you have seen this drawing before, but like I said, we've implemented PNRDs in COMOS quite successfully. We've done most of all our instrumentation in COMOS. We started doing some of our electrical in COMOS. We've done some integration to the PCS7 system. I'll talk about that a little bit later. But we still got quite a long way to go, and a lot of our projects have sort of come to an end, and we are moving to the operational phase where we implementing the COMOS database on site, and that comes with a whole lot of issues and things you need to look out for, but I'll also chat about that a bit later. This is just another representation of what we've used within COMOS. So we've done process design, we've done PNRDs, PFDs in COMOS. We've done basic engineering, especially on the instrumentation electrical side. We've done some detailed engineering. We're looking to use COMOS to assist us with commissioning, to create all our commissioning test certificates, to interface to simulation packages like Simit, so we can better test our software and designs up front before we go to site. Like I said, we're also moving some of our databases to operations, where we'll look at how to use COMOS within the operational environment. And modernization, I'll come to that later as well. Okay, some of the challenges we've experienced using COMOS. Like with any other package, it's quite a big comprehensive package, so that there's obviously quite a steep learning curve, especially with the first couple of projects we implemented. And also what we found is we needed to create certain standards and symbols and that within COMOS, that weren't there. And that obviously caused some delays and that. And with numerous projects running concurrently, it's quite a task making sure that the symbols and changes made all align. We also found some customization is required, even between sites. Things like pipeline numbering, wire numbering differs from site to site, so there is quite a lot of customization required. We also had issues where the COMOS workflow doesn't always follow the way the project workflow is done. COMOS workflow basically goes from PFD, PNIDs. Once you've got your instruments on your PNIDs, you can create data sheets for them, do the loop drawings, and create an IO list. But for example, if you're in a project feasibility study, you want the IO list up front without necessarily doing all the loop drawings or data sheets in detail, so that you can get costing for the project. It's not saying that it can't be done, but it's just something you need to look out for. When we first implemented COMOS, COMOS was released on using a database called the CDB, the classical database, and they've subsequently upgraded to an industrial database, which is a far better, more integrated, intelligent database, which means we now need to convert some of our older databases from the CDB to the RDB, especially if we want a common standard going forward. The conversion, unfortunately, is not straightforward and does require time and costs. So we've got 3 databases that we need to move from CDB to RDB. You also need a strategy. Once you've completed a project, you need a strategy of how to incorporate that project into the as-built COMOS library, how to maintain that library going forward. It's not trivial either, and there does need manpower to be allocated to that, to manage that. What goes without saying is try and limit exporting data from COMOS into other systems. For example, Excel. We're all engineers, we like Excel, and manipulating and then trying to put that data back into COMOS, because often data is overwritten or it doesn't follow the COMOS procedures, and things can get lost. So some recommendations for those going forward with COMOS is, as far as possible, follow the recommended COMOS workflow. Limit site and project specific customization if you can. It's not always easy, especially on brownfield sites. And make sure that you use COMOS for what it is, that all the data that you work with sits in COMOS. You don't have, again, Excel spreadsheets sitting on the side, with data that differs and is not part of the COMOS database. Some of the benefits we saw using COMOS, especially after the first few projects and ironing out some of the teething issues, is it's a single platform, it's an integrated database. You definitely see benefits from that. Information only needs to be changed once. So if somebody changes the size of a motor, for example, it's updated on the PNID, on the single line diagrams, on the load list. It's not separate documents that need to be updated and aligned. There's obviously better collaborations between disciplines. Everyone has access to the latest information, and there's one version of the truth. There's also improved revision management. Revision management always be quite difficult in a project where you have multiple multiple disciplines, multiple people working on different Excel spreadsheets and Word documents. No one quite knows which is the latest information, but COMOS handles that quite well. Yes, for Greenfield project, we also found you can do the initial download to your control system. All your IO list, your IO allocations, your basic function charts, function blocks can be created automatically, and that saves quite a lot of time. One of the things I am looking into is to ensure that sites keep their documentation up to date is on a routine basis, is to compare the information from the control system with the information in COMOS. So if all of a sudden a flow meter or something appears in the control system and it's not in the COMOS database, you can go back and say, the documentation for that wasn't properly completed. The future of COMOS in Anglo Platinum, like I said before, we want to use COMOS to assist us in our commissioning by creating test certificates and interfacing to simulation packages like Simit. We're currently testing, which Reimer might discuss, is putting our databases on a cloud service such as Azure, so that all the stakeholders can access the latest version. Currently, our databases either sit with the engineering company doing the project or on site, which makes it difficult to access the COMOS database, which kind of defeats the purpose. Also, hosting it on the cloud will allow us to better utilize the licenses we've purchased for COMOS. We're also looking at integrating COMOS with other systems like 3D models. We're doing quite a lot of 3D scans on our sites, so interfacing it to those, our plant maintenance system, our plant control system, our data historians, Simit, etc. Sorry, have I run out of time? And yes, in future, we want to use COMOS for all our documentation. That includes Word documents, process descriptions, etc. So there's one source of information. And to implement workflows for day-to-day plant changes, so that approval of changes on site and that can be automated. We're also looking into migrating to a full digital twin, but I'm sure Frank and that will discuss that in their presentation. Thank you.
Thank you very much, Marc. I hope I'm audible to everybody. But yes, what is exciting is to see that there was a real reason why COMOS ended up being implemented at Anglo, and it was due to a safety incident that happened at BMR. And we are quite excited that although it's taken 10 years to get where we are, to do just 3 blocks on your diagram, let's see, this is one of those things. Let's see how quickly we can get to the top right of our COMOS progress without taking 10 years. Can we have that period? But Marc, thank you very much for the very informative session regarding the journey with COMOS and Anglo. We're going to have on stage Ian Gebbie. Ian Gebbie is going to talk more about the multidiscipline engineering design packages. We will see what Ian and DRA are using, if they are using in COMOS indeed or something else. Ian, welcome, and over to you.
Good afternoon, everyone. It's a pleasure to be able to talk to you and share with you. Let me just see if some slides come. There we go. As Theko said, I'm going to discuss how we're using our design tools and also sort of just touch on how ready we are in the digital twinning space. I'll touch a bit on digital twinning as it does mean many different things for different folk. I'll then take you through fairly quickly on some of what we've developed within COMOS, touch on some of the gaps as we see them currently, and then some of the issues that we've seen in using the tool in a project environment. Just before I get started, DRA is an engineering house doing EPCM and EPC projects, everything from mine planning, open cast or underground services, through to water in my department, or the EC&I engineering, operations infrastructure, quite a bit of energy work happening at the moment, and ports and harbors. Digital twinning, what do we mean? If you look at IBM's definition of a digital twin is a virtual representation of an object or system that spans its life cycle. Very important aspect of the definition, is updated from real-time data and uses simulation, machine learning, and reasoning to help decision making. I don't think we're quite there. We are, however, using it as a design tool to model what we intend to build, and you just heard from Marc, from the owner's point of view, then gives you a platform to maintain the system through its life cycle. From our point of view, there are many things that could go into the digital twin: instrument designs, electrical designs, simulations, process models, 3D models, structural models, etc. Later on, I will show you what we are using and what we are not using in all of that. So COMOS, I think this is a different representation of what Marc has just shown in terms of the timeline, in terms of the tools that are available. What I've highlighted here is the aspects of COMOS as we as an engineering house are using. So we're using the P&ID tools, we're using the piping tools, we're very certainly using all the electrical control and instrumentation tools. There are aspects of it in the broader life cycle that we'll enable, but we're not necessarily the end users. So where are we? What do we have currently? DRA, we're using the P&ID tools, so we're doing all our piping instrumentation diagrams in COMOS, and we're integrating that process data right through to instrumentation and electrics, which is why we'd want to use these tools and where their strengths are. Electrically, we're using the package as well. We're pushing out cable schedules, schematics, cable block diagrams, etc. We find all these tools, using them from instrumentation drives them, and we're certainly using them already on generating data sheets, loop drawings, wiring drawings, hookups, etc. And we started pushing it into the control space, using it for IO counts, IO assignments, network drawings. I'm going to leave this on the slides for your reference, but for interest of time, I'm going to talk through, over them. But this is an example of one of the many P&IDs we've done using within the tools. It just happened to be a large conveyor coming out from underground. So all these symbols that you're seeing here would have process data and instrumentation data behind them, which is why these tools are so important. That data is then available to us from a design point of view, but also available and a maintenance point of view through the life cycle of the operation. Again, electrically, the tool is getting used in our design platforms. This is an example of a LV single line diagram showing a MCC and its distribution that allows me to see what starters are assigned where, and cables are assigned to particular loads. This is a schematic I've just taken from one of our projects that we're busy with at the moment. So again, the power on these tools is that the information is live. If the size of this motor had to change, the schematic would get updated automatically. If I change the cable data, the schematic would be updated. This is an example of a loop drawing. Looks like a a 4-wire instrument. Well, I'm going to have to go and study that a little bit actually, or I've got an auxiliary alarm on the top there. So a lot of complexity is available for us within the tool to produce instrument drawings and loop drawings in the way that we want them. We are fairly particular about the detail that we want on a loop drawing, and the information. You'll see we always try and get power supply information through IO cards and then shown out. In the past, many of the tools would only give you from IO out, and you couldn't actually follow the whole circuit through. On COMOS, we're getting the outputs that we want in the way that you can see the full circuit and then help you with fault finding. This is a very powerful aspect of COMOS. I'm afraid the text will be a bit small for you to see in your format, but cable block diagrams, I can give this to a contractor and say, right, these are all the cables that you're pulling, give him more of a holistic view. He'd obviously work with us together with the cable schedule as he's pulling, but use this to plan his construction job for the day. We're starting to use COMOS and bring in aspects of our 3D models. We always have extensive 3D modeling on any project that we build. Instead of doing a 2D drawing within COMOS, we're now linking in all our instrument tags, process tags, to highlight where things are, and then we'll hand this over as a location drawing to a contractor so you can see where the pumps are, where various instrumentation is on that particular site. The 3D integration that we have so far within COMOS is limited, and it's probably more of us as a user need to investing more time to get our existing 3D tools to integrate into COMOS. This is quite unique for the design tools that are around. We're seeing COMOS being structured to allow close integration from instrumentation design into control systems design, which we like, especially as a lot of our designs, let's say if you're using EZBus, for example, the integration between control and instrumentation is very tight. We can pull out the network drawings that we want done in COMOS, link that through to our PLCs. We haven't closed that loop yet, but we certainly know that it's possible. But this network design was done in COMOS, and we would construct off documentation like this. So how do we use the design platform? At the moment, we use it for our electrical control instrumentation design. We use it for our process design and PNIDs. We can see the benefit of using it in our logic designs as part of the control systems work. What we don't do is we don't do it in our 3D integration. So there is a gap. How do you go from PNID piping instrumentation drawing, the instrumentation side is strong, into a piping space that you can do piping engineering? And in the workflows that we have and in the modeling tools that we have, we're working quite hard at the moment on what that integration is going to look like. At the moment, it'll be an export of piping lists and numbers and specs into a separate package that we've been using for our 3D piping design and our 3D model space design. And then we don't use COMOS on a simulation point of view. So the mass balance from a process point of view is done elsewhere. The load flows electrically, we still do elsewhere. And there is use something like ETAP. Often that is done still on Excel. And then the results of that would inform a single line diagram that would come into the tool. All right, so why would people want to use COMOS? And I think you've heard the benefits from Marc that's just spoken before me, that you have a tool now that will give you a representation of the design and how it's been commissioned, and can be used through the life cycle operation 20, 30 years down the line. So many times the client's going to make small changes to instrumentation, electric design, small little projects. It's not worthwhile bringing in an EPC to go and manage that. You want folk on the site to say, right, I want to go and add another instrument, or I want to change the size of this motor, but you want to keep that data up to date. It means that this whole database, this twin, if you like, moves over to the client, and he does it as an engineering tool and then keeps it up to date. So we're seeing small projects with design updates. We're seeing the operational folk having access to the design information, all the IO allocations that we made, all the sizing information that we used. You can update those changes. You can produce maintenance schedules down the line, and you've got access to all the data sheets that you can use for maintenance and purchasing the spares, etc. We have seen some traps. On the positive sides, I've got multiple people working on a project at any point in time. I've got sharing of data going, which is better than we've had in many other tools, between process, instrumentation, electrical, and back and forth. We see the tools being able to define maintenance needs down the line, although our primary focus as an EPC is to construct. We certainly see the advantages coming down the line. COMOS has been difficult from a setup point of view. The data structure of any design tool like this needs to take into account the engineering workflow. Too often we see design tools that says, if you want to add an instrument, go and select the model of and make of the instrument that you are going to use and drop it into the design. The real world doesn't work like that. When I start a project, I know that there is an instrument there maybe. Then as it colors in and the design develops, I get to go, okay, yes, there's a level transmitter, and yes, I think it might be an ultrasonic, but which vendor, which make, which model, I don't know yet. But I do want to start putting out data sheets. I do want to have a tag assigned. I want to be able to get process data. I want to be able to get mechanical data, tank heights, etc. And then I want to be able to color that information into much more detail through the engineering process. And there are not many tools that can do that. We've made a lot of modifications to the COMOS structure to enable this, to enable the tool to be used in the engineering flow. Then we also, and it's one of the issues we're struggling with at the moment, there needs to be a controlled flow of information between disciplines. I can't have ordered a flow meter from a manufacturer, have it sitting at the workshop, and then find the process engineers decided he doesn't need it and deleted it, and I don't get to know about it as an instrument engineer. That whole workflow and consequence of change needs to be managed within the tool. Again, that is a setup issue on COMOS that currently we're struggling with. We see the tool can be doing, but we're going to have to rework some of the setup to enable that between its working layers, so that if a change is made by a third party, we can manage that change in each discipline. There are other design tools that do this a lot better. I'll touch on that just now. And then, how do we control access to who changes what? How do we control it without destroying the initiative of the engineers that are working? We as DRA do use other tools. You heard Marc talk about InTools or the smart plant instrumentation. We currently engineer extensively using the DESsoft, which is the old derivative from the Pi systems. PISA system rather. We do probably half of our projects at the moment on the DESsoft platform, very strong on instrumentation. We've struggled with it on the electrical side, and we've never got the traction on the PNID. So COMOS has really got our process team and our instrumentation team working closely together in a project that we've never been able to achieve to this extent before. There are other tools that we're investigating. The Viva suite is of interest. The ePlan suite has evolved extensively from a process point of view, and some of the data structures are a lot easier. So, depending on the client and the platform, there are some other tools that, from an engineering point of view, give us some advantages. All right. Thank you very much. I hope you found that interesting, and I'd be more than happy to field questions down the line if anyone wants to know more.
Thank you very much, Ian. Yes, the interesting fact is also the gaps that DRA has identified. And I hope, as like the rest of us, that sessions like this would then, end of the day, come up with a plan on how to address some of the challenges that yourselves as DRA, and I suppose all the other EPCs are facing. So thank you very much, Ian. There is a couple of questions, but we'll save those for the Q&A session at the end.
Perfect.
Okay, I believe I am next stage. I'm just going to prepare my presentation. Am I on? Just want to make sure. Am I okay? Am I on? I'm not seeing the platform. Okay, sounds like everything is fine. Yes, thank you very much, everybody. It's been an interesting couple of sessions already. So FrequencyShift, yes, we are the COMOS design assistant. So we concentrate mainly on the implementation of the platform or the software or the tool. So we're going to take a different angle a little bit. So we're going to look at the human side of it. So we're talking about, yes, the technology is great, but how do we make sure that apart from us who are in this platform, how do we get to the mainstream customers? So yes, look, yes, the digital twin point of view, we're talking about COMOS specifically. So what are we talking about? We have all seen this already. From our point of view, the digital twin journey will be possible only if we can go ahead and do all this from technology point of view. So your DRAs, your EPCMs, Siemens, EDMs, we need to make sure that all this can be possible. And of course, that's our view. Only then would you have a meaningful and useful digital twin concept supported by COMOS from the user's point of view. While we do this, let us not forget the technology users. So what are we talking about? We're talking about the guys that will be given this tool on site to operate their plant that they are used to, let's say for past 20 years, they are used to a certain way. Now all of a sudden we're introducing a different tool. The guys that have to go and fix when things are done. EPCs, we often go and we walk away. But what happens to the guys that are left behind? The plant managers, how do they manage new technology introduced? How do we then, after we've walked away as COMOS implementers, how do we make sure that there's enough customer support? Where do we find the skills? The HR managers, they are affected by the decisions that we do. The institutions of learning, do we have enough universities, technicons, and other institutions providing the skills that we require? Where are we going to get all the engineers? What are we then saying to the document controller on site who's had a job for 30 years, looking for drawings in a system that they know or in a cabinet? Now all of a sudden we introduce COMOS and nobody knows what happens in COMOS. What are we saying to those? And the project managers, do they have full visibility of what happens in COMOS? Maybe yes, maybe not. Cost. Everything has cost to it. We align with the budgets that the different operations have. Are there opportunities as well for the would-be entrepreneurs or small businesses. As soon as you introduce this, we must remember that we end up with different people with different requirements, with different needs that are now affected by the technology that we introduce. I'm sure you will all remember that not every great technology makes it into the mainstream. The way we're seeing COMOS is that we are still in the early stages where you've got innovators and early adapters. Those are the guys that are still using COMOS. To get to the mainstream, it's not as easy as we think. Despite the great technology that we have, it's not going to be as easy as we think unless we address the needs and the circumstances that our majority customers are facing. And those are not sitting this platform. Those are running the plants, those are managing the plants on site. So what are we looking at? Yes, there is a gap in there where we can either, I'm sure if we make an example, tools like InTools and other tools that Marc Anglo used to use before, why did they not go into the mainstream as the main platforms? It's because perhaps, yes, it was early days, but perhaps we did not address all the requirements that the majority of customers need. So let's look at some of the challenges that we are facing with. For us to cross this gap, for us to get to the early majorities, to the late majorities of our customers, for us to make sure that the technology is accepted, there's a couple of challenges that we must overcome. Yes, we have already said it is a new tool, so we need to be cognizant that we are in the early stages. Make sure that you understand that the investments that we have in the initial stage might not have the fruit immediately. It's only later. Unless we understand this, we might think that we're wasting our time. People are considering COMOS as a complex tool compared to other packages. How then do we address this? This is where we need to make sure that people like EDM and Siemens, we make sure that we make the tool as easy as possible, especially when it's compared to the other tools. We must also bear in mind that we're still dealing with large operations that are still siloed. I'll make an example. I might just be a company that only does mechanical designs. I will have my preferred tool. And why should I move to COMOS if it's not going to help me see the benefits as an EPC? So we're going to end up with silos still continue. So it's one of the challenges that as the implementers or the industry stakeholders of COMOS, we need to see how we address. Marc has already alluded to this, the changes of databases from CDB to IDB. We found out that there were almost no standards, no templates available in the new database. Yes, we have overcome that, but what happens again, maybe 10 years from now? Frank will have to let us know of the COMOS journey. What happens when we get to that point and we are starting with a new database? We need to make sure that we overcome such challenges and make sure that at least things are backward compatible. And still, even us using COMOS, I don't believe we've got a full view of the capability of this tool. We are using it, as Ian has already indicated, we are currently using it as only a design tool. But we know COMOS has far more. What should we be doing to make sure that we get to the other benefits of COMOS which are hidden? The main issue for, say, COMOS implementers or Siemens or EDM or people that want to sell licenses or want to support, the issue is we still have a very low customer base within the South African environment. I would imagine, of course, within the African environment. So how do we make sure that we can stimulate the market so that we progressively have more and more customers? Of course, the more and more customers, it means the cost of implementation costs would possibly go down. The other issue we have is the ecosystem itself is not well developed. There are a number of people that have heard of COMOS, but they have nowhere to go. There's also people that are interested in setting up businesses for COMOS, but they don't know where to start. So we need to make sure that we develop an ecosystem. It's going to take long, but that's one of the challenges that we need to overcome. Do we have adequate support? So if Anglo was to go to COMOS today, would we have adequate support to make sure that the guys on site or anybody or any other smaller EPC, larger EPC, when they use COMOS, there is enough support? So that's one thing that we must address. The other one is, yes, COMOS, what sort of skills do we need? There is a challenge. Do I need highly experienced engineers and designers, or do I need people with software skills, the younger guys? So it's one thing that we need to also remember, that we don't currently have the adequate resources to implement COMOS. So we need to do something about the resources that are available in South Africa and in Africa, indeed. The other one is more of a paradigm shift. People still believe that, you can't teach me how to do my work. I still prefer to use Excel, or I still prefer to use a tool that I've used for so many years. Now you're coming up with this new tool. We need to make sure that we overcome that. And it's by making sure that we understand their needs, their circumstances, and make sure that one way or another, whether it's, as an example, by providing a view station for the guy to have an insight, but let's make sure that we don't exclude people that have used other tools and are not prone to using new tools. We need to address that. The other one is, often when EPCs, small or large, get a database to be used, say we're doing a project for Anglo, the expectation is, because it's an Anglo-driven or a specific client-driven software, it must have already in it the required specifications, the required database templates. But you often find out that this is not the case. And then the argument often becomes, who should be paying for the development of the templates and the specification within the database? For example, when we moved from, as Marc had said, when the move was from CDB to IDB, then the development within the IDB, who takes the cost for that? Is it the EPCM, or is it the software supporter, or is it Siemens? That's something that we should all be looking at and trying to address. And the last one is, it takes upfront investment, whether we're talking about the hardware that is needed, the software that is needed, or the training of the people that are going to use COMOS, the training of the people that need to design in COMOS. We must all bear in mind that it is an investment needed to implement COMOS. So yes, this is how we think we should be addressing the mainstream requirements. We should not only concentrate on COMOS, the technology, but we should concentrate on the other softer parts of COMOS implementation. Look at your customers' jobs to be done. So the guys on site, what is their job that they are meant to do? What is their KPIs? And what are their needs? Can I use COMOS to address those needs? Are we introducing a better customer experience, or are we making things worse? If I am a document controller on site, you introduce COMOS on my side. Are you making my life easier, or are you making it more difficult? I've got COMOS on my plan, but who do I call? We need to address those. We also, I believe, for us to progress, we need a healthy competition within the COMOS environment, whatever that means, but we do need to have a healthy competition within the environment so that our clients have the necessary alternatives that they can go to. Also, something that we need to work towards is making sure that at least there are guidelines, procedures, standards, and specifications that we can implement. Yes, COMOS and the digital twin, for us to get to that point, we believe we should not forget us, the individual users. The individual users at the different engineering companies, the individual users at the operations, and all the other supporting departments that make sure that operations carry on. Thank you very much. That is the end of my presentation. Thank you. I'm going to stop sharing. Okay, next on stage is Chrisna from PwC. So yes, we spoke about the technology side of it. FrequencyShift then touched up on what we think the individual people need. We're now saying, is there a readiness within the country or within the mining environment? How ready are we from the higher level point of view? Chrisna, over to you.
Thank you very much for this opportunity. I want to talk about a study that PwC did earlier this year with the Mineral Council and the Mandela Mining Precinct. So we've launched a 4-hour study where we surveyed more than 30 mining houses. And the objective was to understand how 4IR or the fourth industrial revolution are influencing the mining industry. So we wanted to understand how technology is impacting mining and the way we mine today and tomorrow. So I've selected 4 insights from the study that I want to share with you today. So the first we will go into the CEO drive, the digital champions, what is that? Digital technologies and delivering real benefits. The greatest benefit is expected in the core operations. We will talk about industry IoT and the biggest share of the wallet. And this is where digital twin comes in as well. And then it's all about the data. So let's look at our first insight. So the CEO drives the digital agenda from top down. So it's consistent with all the findings with other researchers that we've done since 2015. However, the solution derived from the CEO are typically in the back office, finance, and support services. So the solutions create them from the bottom up, initiatives from the operations, and are driven from the technical head. And they're most beneficial from a return on investment perspective. However, the drawback here is that the technical approach involves long buy-in processes. So let's look at the insight 2 that we got from the study. So this insight, we wanted to understand what the digital maturity stages of mining companies are that they're currently operating in. And PwC recognizes 4 stages of digital maturity. You will see the digital novice. That is organizations that are predominantly paper-based and have very few digital systems in place. We also have the digital followers. They have started their 4IR journey and are making selected investments. The digital innovators are actually working to achieve a smart and connected mine. So from explorations right throughout to fulfillment. And then the digital champions maturity level, we see integrated on safety, people, production, and cost. So you'll see from this slide that almost 70% of the companies surveyed are digital followers, which means they are looking for proven technologies and focus on cost saving and improved efficiencies. So let's look at insight 3, where digital technology are delivering real benefits. So we found that there are 4 major reasons why mining companies will invest in digital technologies. So the first is to improve safety. Second is to increase efficiency, throughput increase is third, and then obviously cost reduction, and there's no specific order for that. But we also find that mining companies are taking careful but calculated steps to this journey. That means that they would like to have a business case and use this to justify their investments. The study also found that it's perceived that the greatest benefits will be in the production space. However, these programs are most difficult to implement in these areas, as you can understand. So 4IR technology should enhance the global competitiveness of mining companies, and not only productivity and cost, but also the so-called ESG, or the environment, social, and governance issues. It's worth mentioning that the people aspects of 4IR, and most respondents believe that there will be a change in the nature of the workforce over the next 5 years, with a transition from a more skilled employee. So this means that we have to pay them more. But while respondents are concerned about increasing labor cost, the majority believe that the production gains will be more than the offset of those increased costs. So 79% expect production costs to actually decrease over the next 5 years when they use 4IR technology. Maybe one last item on this slide. I think we find that adoption from the workforce is key. So you have to remember that people remain in the center of the digital transformations. And we have also seen some brilliant projects that fail because adoption is not there. So continue from the previous point, Insight 4 shows us that the greatest benefits are expected in the core operations. So mining technical functions such as rock engineering, survey, ventilation, safety, as well as asset management, maintenance and repair are the primary beneficiaries of the 4IR study. This reflects the drive to visualize and manage operations in near real time, so giving mining companies the ability to respond quickly, as we would say, let's save the shift or let's save the blast. So IT functions have an important role to play in all of this digital transformation, and we also see that significant overall of IT. So IT will change drastically from a service provider to a business partner that will drive technology in business. So another important point we found, the adoption is key. So remember, people are the center of this transformation. I've just mentioned it in the previous one as well. So let's go to the next one. So Insight 5, we're looking at industrial IoT and the technologies of who gets the biggest wallet. And we find that the IoT, outperforms in this space. And it's not surprisingly at all. I mean, these technologies are relatively cheap and simple to install. We've got more than 90% of the respondents have already implemented some form of IoT, or they piloted, or they plan to do this in the next 5 years. But let's move to the digital twin technology. So what we found from our respondents is that this is implemented by 21% of the respondents, while 26% are piloting and 16% plans to use this technology in the next 5 years. So there's a great outlook. So, but unfortunately, at this point in time, there's about 40% that has no plans in this regard. And let's hope that this conference is one of those steps to take them in the right direction. So AI machine learning is also important, and only 11% of respondents is starting to piloting those. So that brings us to the Insight 6, our last insight. So with regards to this, we wanted to gain more technical insights into how mining companies, view the data and how they manage it. So all the mining companies that were interviewed agreed that data are the fuel for 4IR technologies. When we asked them how they would describe their ability to use the data effectively, the decision making, 53% said that they would like to have the operations optimized. They want the data to be accurate, real time, credible, and they could rely on it. That's, as we used to call, one version of the truth in mining. So we all understand the power of data in the new 4IR age. So personally, I find that companies struggle to implement this integrated end-to-end view easily, and the data should rather be seen as a strategic play rather than a project or something that we have to do to implement a project. So this concludes us on this high-level study. I think it was very quick that we've done. The insight was very valuable, and we're going to repeat this the next year. So if you want more insights on this topic, you can look at the web for the 10 insights. You've seen I've only listed 4, so there's 10 insights to 4IR study. So thank you. I think that's all that I was given time for. Thanks.
Thank you very much, Chrisna. It is also very interesting the fact that your study has also indicated that the thing to consider, which is at the center of it, it's the people. which is almost a follow-up of what we were talking about. And it's also interesting that you're saying that that is where projects fail, irrespective of how brilliant they were as an idea, how they failed because the people's needs were not addressed. Thank you very much for that. Just a reminder to everybody participating, there is a chat where you can post your questions. Some of the questions we might not be able to answer during the live session. Those will be addressed at the end during the Q&A session. But please make use of the Q&A session towards your right-hand side. It looks like a chat button on your hands. Please make use of that for any questions that you want. Up next, we have Reimer, who is the MD at EDM. They are looking after COMOS and predominantly the software as well as the COMOS databases for Anglo and other clients. Reimer, welcome. Thank you very much for your time. Over to you.
Good afternoon, everybody. Welcome to the Digital Twin and COMOS presentation. So I would like to go a little bit into this question that was asked about what is the progress in the South African market with COMOS and the digital twin. So I think the first thing we need to understand there is something about this digital twin. Yeah, the digital twin is basically a virtual representation of a physical plant. Let's call it a plant in this case. And we use this digital twin to understand and predict the real plant's characteristics. And what is important to understand is that this digital twin is used throughout the whole life cycle of the plant to simulate and predict and optimize production of the plant before we invest in physical assets. Yeah. So if you look at the different life cycles, COMOS is of course the basis of this whole digital twin platform. And if we look at the life cycle of the plant, the first cycle would be our engineering design. And when you look at how we use COMOS during the engineering designs, COMOS is basically the tool that integrates all disciplines in one consistent database, yeah, where all the disciplines and all the data is put together. This is important to understand that this database is the root for the digital twin. Yeah, an important part of this during the design is that we have the possibility to integrate with the control system. Yeah, there is a bidirectional interface with the Siemens PCS7 system available, which means we can, especially on greenfields, automate the software and hardware design for the DCS and exchange hardware configurations, I/O descriptions when it comes to the hardware, but also when it comes to the software. All the function blocks can be predefined in COMOS, changed in PCS7, and later back into COMOS if there are changes made. The COMOS software suite also supports the mobile solutions module, which basically makes sure that every stakeholder gets access to the data in the database, maybe just as a view option via a web. Maybe the guys can via web update additional documents like manuals or maintenance data sheets, etc., that they receive or download. They can integrate them into the system for maintenance purposes. Benefits of using COMOS during this engineering design cycle of a plant would be that we would have 30% less design time and 20% lower costs. But then we get to the next phase of the life cycle of the plant, that is the installation and commissioning phase. Yeah. So how can we make sure that we can use the software and the COMOS suite during this commissioning cycle? Yeah. We have of course, also the integration with the CIMIT software from Siemens next to the PCS7 interface, which basically means we can virtually commission a plant before that plant is physically built. And this is, of course, a huge, big part of a huge advantage that you can test things upfront and get information about how this plant is going to react in real time. An important part is this simulation is typical digital twin technology. Yeah. The switch can later, when everything is commissioned, you basically switch from a virtual plant in the field to the real plant. Yeah, but CIMIT will always be able to assist with, if you want to make a change in the plant, you can test and simulate that on that platform before you operate it. It will definitely help you with a smooth, effective system startup of the plant. Then we have the COMOS Walk Inside module, which basically uses the 3D model that is created either during the design phase of the plant, or it can also be created with laser scan or photogrammetry. But basically, the Walk Inside module uses an existing 3D model, and we can use the Walk Inside for design reviews, operator trainings, or remote operations, which can assist us also in preparing the site personnel for the actual control of the plant upfront. Benefits during commissioning up to 80% time savings, and we can significantly reduce the risk for errors, accidents, and we will definitely have a cost saving. The third phase of the life cycle of the plant, the operation and maintenance. Okay, what do we see here? If we use the functionality of COMOS with PCS7, we will make sure that our documentation will always be up to date because we have this bidirectional interface. The changes made in PCS7 will be put back into COMOS and will be definitely documented properly, which is an important part. It is important to keep the documentation up to date. The mobile solutions is a powerful tool of the COMOS suites to do the maintenance management of the plant, and that even includes having mobile devices to add information that is done in the field to the COMOS database, so that if you do maintenance, that you keep a proper history of what happened to an asset. It also enables consistent flow of information. Everything should always be up to date, and everything flows back into your main database, COMOS. Then we have the CIMIT training module, which can be used to train operators. And then we have here a very important part of the digital twin is the XHQ module, which enables making decisions in real time. So the XHQ product basically is the tool that can connect to several data. Actually, almost every system that is existing in the plant can create a link to this system and retrieve data from these systems for display. Yeah, so this is where your operational information will be online displayed. Benefits of this product will lead to an 8% reduction in operational cost, and can be an up to 10.5% increase in productions. And of course, we have better decision making because we retrieve actual data from all systems required, and that is, of course, essential to making these decisions. So these 3 life cycles will give you the different information. And then I get here to my last slide, where we can see that if you look at how far are we now with the digital twin in South Africa, we basically, depending on the sites, we are doing first tests. Yeah. On other sites, we have COMOS properly integrated. First tests are being done with the interfaces with Siematic PCS7 and CIMIT. Yeah, there is a site where walk-in site is being tried out. There is a project going on where XHQ has its first project in the South African market. So slowly we are getting there. Of course, we are far from having all functionalities implemented. Okay, so we have, to conclude, we have still a long way to go, but we are on the right track. There are a lot of technical questions, of course, popping up during these implementations, and it is definitely not a short journey. We will continue slowly and definitely be successful. Thank you very much for your attention. Back to you, Theko.
Thank you very much, Reimer. And there's a couple of points that I picked up, and I am glad to see that as far as training is concerned, we have a module that can be used for training purposes. But also it's very interesting that there are sites already where EDM is piloting some of the functionalities of the digital twin. So we have seen that from EPC's point of view, it's still a design tool, but it's also nice to see that the dream that Anglo has, you are already piloting some of those functionalities. Yeah. Thank you very much, Reimer.
You're welcome.
Cool. Up next is Frank. Frank, the global partner manager from Siemens, Germany. Frank, welcome, and thank you very much for your time. We're looking forward to see, as the last presenter, to see what is in store for us from COMOS Siemens point of view, for us to be able to overcome and to achieve some of the dreams that we have with regards to COMOS. Frank, over to you.
Thank you very much, Theko. Thank you for your kind introduction and also inviting me to today's session. It's actually a great pleasure to have the chance to talk to the South African market and even beyond there. So what I would like to do is to give you an overview about the solutions that we offer to implement a digital twin and also to position them. The positioning is very important from my belief, as there are a lot of different understandings in the market what is actually a digital twin. So I would like to start with a quick look back where we as Siemens are coming from and our drivers for our customers. Then talk about our lifecycle management tool COMOS and some of its most recent developments. And at the end, I would like to show how we then can come to an immersive digital twin solution. I hope that fits your expectations. And with that, I would like to start with a quick look back. Siemens actually started its own digitalization journey from a very strong position in automation already in 2007. At this point in time, we acquired UGS and also Innotec with the COMOS solution as a starting point. And then more and more solutions, and with that more and more companies were added. So that we are now above $10 billion in terms of investments taken to provide an as complete as possible solution for our digitalization journey to our customers. So currently we are amongst the top 10 software companies around the globe, and for industrial software, even #1, with almost 25,000 developments and over 3.4 billion euro of revenue. I believe that is a quite good proof of sustainability and also of capability to accompany our partners, as you, for example, and customers in their digitalization journey. When we start talking about software solutions for process industries, we always have the following main levers in mind. And I bring that up at the beginning so that you easily understand the ideas behind these solutions. Digitalization can give a lot of benefits, but need to be put into the context of our customer strategy, as we have already seen today. Data consistency is very important, as still our customers spend a lot of time and with that a lot of money to find the right data. Means who has actually the right data? In which system are they? Which data are the most recent ones, and so on. McKinsey did a survey, and the outcome was that on average, every employee of our customers still invest 1.8 hours a day just to get the right information. 1.8 hours a day is almost 1 working day per week, which is 20% of the time. Scalability is very important. Digitalization solutions should start small to keep all the looses and ends together, but need to be able to easily scale up or downsize again. Global collaboration needs to be seamlessly possible. Company internal, but also external with subcontractors or partners. Third-party data integration. That is because all our customers do not start from scratch. They already have an infrastructure, they have tools and systems, and we need to be able to integrate all this already existing information and add additional value to our customers. And all that together helps combining the real world and the virtual world and keeps finally the digital twin evergreen. So when it comes to our portfolio, we are talking about COMOS, the engineering commissioning tool that sets also the basis for operations. We are talking about XHQ, our operations intelligence tool that adds the information of the process and the assets on real time during operations. And about PlantSight, a kind of umbrella solution putting both capabilities together and even more, and with that provides the most comprehensive solution. So let's quickly start with our COMOS solution. What do we have new here? It's actually that we developed additional feature for what we call modularized engineering. What does that mean? It means we want to make the life easier for the engineering and design departments of our customers, for the process OEMs or the EPCs. Just adding a functionality that allows them to standardize their bidding process. Typically, you get a request from a customer like an RFP, for example. That RFP might include the specific customer requirements, the needed capacity of the solution, environmental and governmental regulations, and so on. As these departments are very often specialized with a certain repetition factor, we can develop a template and rule-based solution for their customer proposal. We are finally able to build a decision tree where the employees are clicking through, pressing the button, and the solution provides the proposal documents, like the technical specifications, bill of materials, schematic drawings, and so on. And all that automatically. And the even bigger value is in the negotiation and execution phase, as you save a lot of time when changes need to be made to the proposal. And finally, the proposal needs to be transferred to the engineers for execution. That solution saves a lot of time and prevents from doing failures, for example, due to just copying and pasting from former projects. What is new with the integration of CIMIT, PCS7, and now also GPROMs? We have already seen the capability of making use of COMOS automation engineering for PCS7 configuration and that combined with CIMIT. And we are now adding GPROMs from PSE. PSE stands for Process System Enterprise, is an advanced process modeling company which Siemens acquired in 2019. We can bidirectionally exchange data from COMOS that allows the process engineering with data from GPROMs, where the process streams are simulated. This means that we can link and simulate what is happening in the pipelines that are planned with COMOS. That is actually a big step forward. Above that, a powerful combination is SIMET and GPROMs together, which can be seen in the lower right-hand corner. Because we can overlap and simulate both now, the process streams with GPROMs and the automation part with SIMET. This lays the foundation for the digital twin with the solutions you can see here. This combination of engineering, automation, and simulation enables the user to optimize the plant's productivity and the performance using predictive models. For operations, we improved our maintenance solution by adding the mobile worker functionality. Imagine your people go into the plant and get all the necessary data like this. Location-based, role-based, in time, and as needed. The typical use cases we can support with our new solution are in the commissioning phase by getting all the needed data on your mobile to fulfill your tasks and check them. It can support you for inspection and mobile maintenance by providing the needed documentations, work tasks, spare part availability, execution fulfillment, providing feedback with redlining, or adding photos. You can ask your subject matter expert, if needed remotely, and visualize what you see in the plant so that he can guide you. You can compare as built against as is information and can manage turnarounds. But these are just a few use cases. Happy to discuss more with you that are possible with that solution. With COMOS, we have the engineering digital twin, and COMOS also builds the basis for operations, but it is not enough for operation, not complete. We are missing here the data out of the plant, from sensors, data from historians, from business systems or supply chain, also perhaps market prices. That is what we can get with XHQ, our operations intelligence tool. XHQ is built on a 5-step approach, connecting to different sources or tools, collecting the needed data, organizing them in a meaningful manner, and contextualizing them so that the outcome can be visualized as KPIs and trenders, for example, in a dashboard, and all that on real time. The journey starts with connecting to different sources, like tools for analytics and optimization, like business systems as SAP, Oracle, for example, plant systems like LIMS or historians as OZPI or AspenTech 21, could be engineering tools like COMOS or Aviva, Bentley, AutoCAD, whatever you can think of. Bringing both together into a cloud-based asset portal makes the solution then complete. That is a new kid on the block, and we call it PlantSight. This is a solution we developed together with Bentley. The idea is to get together the data from the virtual plant, like you see on the left side, so design data, data from simulation, from process modeling, forecast and asset-related data, together with the one on the right-hand side out of the real plant. So could be alerts, real-time data, optimization data. That is the idea. How does it work? The engineering data from the virtual plant on the left might come from tools, as you can see here. They are acquired, means they get a common tagging structure so that they can be referenced to. On the downer right-hand side, you see the data from the plant coming from different sources. They also need to get a common structure, will be connected to the engineering data, and finally visualized. This solution gives the customer answers to very important questions, like, for example, in the phase of engineering to an operator. I would like to have a controlled digital handover and would like to be involved in this process. On the other hand side, you have the EPC, who wants to establish a smooth handover but does not want to risk his IP. Or in a brownfield situation, I do have so many different systems. How do I get a change in my plant properly and consistently documented in all systems? The operator might ask, what is the status of my asset? In operations, reliability of the process is important, and with that to know about bad actors. Or how can I optimize my output? Where am I against my targets at the moment? And all that on real time. Or for EHS, how to ensure environmental protection? How can I get my people trained without stopping the production? All these scenarios are very common and very important to our customers. And with PlanSight, we are giving the right answers at the right time and wherever needed. Yeah, and with that, Theko, I would like to thank you for inviting me again, for listening to me, and would like to hand over back to you. Thank you very much.
It was an insightful presentation to see what are the capabilities as far as Siemens is concerned. And with that, we are done with our presentations. There is a number of questions that we, as a panel, have to respond to. So we're going to move straight into the Q&A session, if okay with everybody. I'm just going to give everybody about 1-2 minutes to have a look at the current questions. Some of them have been sort of answered on the chat, but I would like us to maybe elaborate a little bit more on some of those questions. Just give me about 1 or 2 minutes. Let's have a look at the questions that are presented. I'm going to post some of the questions and comments that have been made. One of the comments is, Reimer, are you still online? I would like Reimer on stage, please. Lolo. Yeah, so Reimer, one of the comments is that from Glenn is that he met you a couple of years back and he's glad to see you, né? At the time, he thinks you were just a dreamer, but
I saw that, yes.
he realizes that you were seeing 5 years ahead. Is there any comment you have on that from Glenn?
Yes, it's been quite a journey, of course, to start this this whole COMOS process. And to be very honest, in the first project when we started with RBMR, it was we actually learned a lot in that first project. And I can also say that in that first project, the first database, we made mistakes, and all part of the learning curve, of course. We were in the next project at Mogalakwena South able to correct a couple of mistakes so that we actually already had a better database than the one before. The Polokwane SO2 abatement project was the third project we did. Even there, we have made huge improvements to the database. And then after when that project was finished, we started with the IDB. which basically was a possibility for a fresh start and a possibility to create a standard in the database for Anglo from scratch. And so instead, we didn't at that stage have a possibility to migrate the databases, which is also maybe a huge advantage because we were able to start with a clean slate and make sure that we didn't make the same mistakes again that we did on the CDB. Yeah. But again, there was again a learning curve because the IDB, of course, has the possibility to be updated with every new release that comes out so that we get the latest data onto the system. And we have been doing quite a bit of work on the EDM side to make sure that we can accommodate these updates without projects being affected. Yeah, so thank you, Glenn. We have on Magala-Quena Noord, I think all the PNIDs, PFDs, and network drawings are currently on the COMOS database. Yes, and looking forward to do the next project. Next steps. I can't hear you, Theko. That's better. No, that's not better.
Reimer, thank you very much for responding to that comment. I'm going to ask Ian to go on stage. So the reason I'm getting Ian on stage is there is a question of COMOS versus the smart plant instrumentation or smart plant suite of products. Coming from a very neutral position, i.e. you have used all these different tools over the years, and you are not necessarily pushing COMOS because you're developing COMOS. So I would want you to sort of give us an insight, and based on your experience, in tools or SPI versus COMOS suite of products. Over to you, Ian.
Thank you, Theko. Very interesting question. Yes, I've used InTools in a Sasol and mining environment. We've used Smart Plant Electrical, done a little bit of the 3D modeling in the Hexagon products as well. And then obviously we've done a lot of engineering now in COMOS. I'm finding, look, the Hexagon products are very good. They're fairly intuitive. Their costs are high. So if you're going to set up the full system to get the functionality that you want out of COMOS, there's a price tag. But they're both good products and they're both effective. What I'm liking with COMOS is the step beyond instrumentation engineering, where we can start pushing into the control systems engineering. We've done it now with some FDES work where we've taken instrument indexes, or IO counts, IO allocations, and motor allocations and pushed it out into XML straight into PLC code as base code to start. But COMOS we're hoping will bring a lot more flexibility on that and help us in our coding environment and to bring efficiencies. And what Marc was saying right in the beginning of this is down the line trying to ensure that PLC code is maintained through to the instrument design. I think COMOS will give you some flexibilities there. I hope that answers the question.
Yes, from my side, it answers the question. Yes. Okay, no, thanks for that. Ian, I'm going to ask you to stay on stage.
Okay.
I would also like Fred to go on stage. There is a question which, if I summarize, it's more to do with, is there a COMOS project that has been implemented where overall time was saved versus the other tools that we used? Is Fred still on the line? I would like Fred to go on stage. Thank you, Fred. So, Fred, I'm going to ask you to go for these questions first before Ian. So, you are also an EPC, large EPC as well. The question from the audience basically is there a COMOS project where you believe time was saved because of implementing the designs in COMOS versus what you could have used?
To answer the question is not a straightforward way. We have these differing opinions comparing conventional with database engineering. So yes, it's going to take you quite some time to populate that database. And the only way to put it into a clear-cut context is if you look at when, let's take a brownfields environment where everything was done conventionally. In order to start that process, you have to take quite some time to update the PNIDs, to redline the PNIDs. And that part is missed sometimes. It can take anywhere between 3 and 6 months, depends on the actual size of the process plant and the complexity. And then from there to take it then into an updating of the drawings, and from there to go into the conventional methods that we currently had at our disposal, be it DSoft or InTools, or whatever the case may be. So that it took a long time to actually gather that information. Now we have the ability to bring that all in beforehand. So I'm not going to be clear-cut and saying it's going to save you time. We must understand that what we're doing here, we're investing in that tool that ultimately will be sitting in the operational environment that the end user can take and now optimize the maintenance and the running of his plant. And it goes back to that one slide that was presented earlier on in understanding what is a cycle from an engineering point of view, from taking from a process establishment point of view, feed, detail engineering, and into commissioning. One of the things that we know is we used to freeze the design at PNID stage and then go into it. It's a different scenario now. That PNID remains live all the way through into commissioning. So the design engineer commission component is only finished when we have finished commissioning and we hand it over to operations. And if you take that whole spectrum into account, then there's no argument that there is a time saving involved there. But from an upfront point of view, no, I can't categorically say you're going to gain time. It's an investment into the process, into the operational environment. And that's simply the way that I am promoting it to all my end users and clients at the moment.
Okay, so it's not as easy as we thought. So it's not clear cut. Thanks for that, Fred. Ian, the same question. Have you seen the benefits of COMOS compared to what you've done?
Yes.
Of course, EPCs are looking predominantly at hours that are spent. Have you seen the benefit from EPC 20?
On a traditional PNID, we were pushing out on Mogalakwena M3C work that we just wrapped up that study now. We're probably pushing out 3-4 in our history. We would have pushed out 3-4 PNIDs a day. We were up to 9, pushing over 9 a day on COMOS. Look, the setup was my team worked hard on engineering, getting symbols right, getting data structures behind there right and in the right place and structured correctly. We put a lot of effort into some development work behind it. But once we hit the peak and we were running, we saw a marked improvement on efficiency, and that information, you put down a symbol, my index is live, it's up to date. I've got an instrument index. I've got data sheets straight off the bat. So we definitely saw that efficiency coming through, and I was actually surprised. This was, we had done 3 or 4 smaller projects on COMOS already, and this was one of the larger ones that we had done. I hadn't expected to see that kind of benefit. I did. Now, going historic back, I mean, I've been doing instrument engineering for 25 odd years. The old Excel base, moving to I went Excel in tools, FDES. I've always seen efficiency drives by you doing instrument engineering in a database environment. But you know that, I mean, Fred, to your point, process guys are changing right to the point that the plant's about to be handed over, and we're engineering all the way through, keeping up. You know, to the point that I used to take my database with me to site and commissioning so that I could do my redlining live. You know, and with various platforms now allowing me web-based tools, I don't even have to do that anymore. I can sit on site and as long as I've got an internet connection in the middle of the DRC or Ghana or wherever, and I can keep my design up to date. So, you know, there have been some marked changes there. But yes, we have seen efficiency drives, but you do put effort in to get the tools to work.
If you'll allow me just to add to that, one of the challenges we used to face during the design stage is getting the process mechanical piping guys to convey their information via the P&ID across to the E&I guys. At least now what you've done is you've ticked all the boxes, populated all the field. So when those changes occur, it's seamlessly rolled out to everybody. And the benefit of that is immense. And then what I'd like to say is you mustn't consider it in terms of actual drawing production or lists or or connection schedules or whatever the case may be. We must now understand that you've got a database which is revved up in the database in a singular space, not on individual drawings, etc. and whatnot. And we come up with a new term. We have outputs appropriate for the purpose at the time. Whether you want to think of that as a conventional drawing, you can think of it as a mechanical equipment list, whatever the case may be. Remember, it's now sitting in that one nice, comprehensive database.
Cool. All right. Thank you for that, Ian and Fred. There is a couple of questions relating to the databases. So I'm going to ask Reimer back on stage, please. Thank you very much, Ian and Fred.
Can you hear me, Theko?
Yes, we can hear you, but we can't see you. I also want Frank on the line as well.
Okay, not sure how that it is. That's better.
Yes, we can hear you.
Okay.
Yeah, so the question, I think it came from Sean. Sean would like to know the complexity or the easiness of migrating from CDB to IDB. And in relation to that question would be, why is there no backward compatibility between the two databases? I'm going to ask you, Reimer, to first respond.
Okay. I think you need to understand that COMOS is a system that can be completely customized to the needs of the customer. Yeah? And if you have a system that is completely customizable, yeah, and which is actually exactly what happened with the 3 CDBs that we have for Anglo, to convert that to a new industry database, which is basically an out-of-the-box database. Of course, you will have to customize again. Yeah. So there are tools available by Siemens to assist with the migration from CDB to IDB. But what you always have to do up front is what we call a COMOS transition check, where we actually analyze exactly what has been customized in the database that we want to migrate, and how can that be migrated? Is it migratable at all? Yeah, and we basically need to have a very good look at the customization done on the database before you can proceed with this conversion.
Okay. All right, Frank, thanks for that, Reimer. Frank, we would like you to answer that question from Siemens' point of view.
Yeah, I mean, there's not much to really add what Reimer has already mentioned, right? And when I have to answer that question, I'm always making use of a kind of picture. It means COMOS, or the COMOS database, is actually something like a container, right? A container, when we are talking about the CDB, a container full of Lego blocks. How you order them, all these Lego blocks, is completely up to you, is, as Reimer already mentioned, completely customizable. And with that, can look very, very different from customer to customer, from site to site, from process to process even. And that is why we have to start first always investigating the situation, and with that giving recommendation how to transition to an IDB. The IDB then still is a kind of container, but has then some boxes and with that some regulations how you have to position your Lego blocks. So some additional rules, some templates that you can make use of, and with that get already the Lego blocks in a certain order. And that is what you need to discuss then before you start a migration with the customer as well. Which kind of boxes you want to have? What are the templates behind? I mean, that is just a picture, right? But at the end, it's more or less a repetition of what Reimer has already mentioned.
Part of the question being the backwards compatibility of the different databases. So we imagine after 10 years or whatever the number of years would be, would we still have an issue with backwards compatibility of the databases? Frank, please respond.
So can you explain a little bit better, please?
So for example, you've got your designs done in IDB. When you go to CDB, there's a couple of, there's amount of work that has to be done to make sure that the templates we had before are available in the other database. Why can't we have a click of a button and upgrade? I think this is what we're finding as one of the challenges, migrating or upgrading from CDB to IDB.
So the way from CDB to IDB we just discussed, right?
Yes.
And when you want to go backwards again,
correct.
You need then to discuss and investigate which kind of capabilities and also even functionalities you are losing. And because with the time there are a lot of innovations coming up. So we have talked a lot about DCS systems, mainly around PCS7, for example. And PC7 and specific database as IDB are pretty much connected to each other. So when you are making use of COMOS automation engineering and send the configuration over to PC7, and now would like to go back, and that is where you need IDB. And when you now want to go back to CDB, you lose that capability. So you first of all need to really understand the business need behind that, and with that discuss the lack of capabilities that you then will achieve. So that makes very seldom sense, right? I mean, you should only do that in the case, and that exactly as you already have mentioned, means customization as well, so additional efforts. So you need to really discuss if that is needed, go backwards to the classical approach again.
Okay, all right. Thank you very much, Frank. Thank you very much, Reimer. Back on stage, I would like to have Chrisna and And Marc, there's one or two questions that are directed to you. Please, can we have Marc and Chrisna on the stage? Yes, the first one to you, Chrisna, is there is a comment that we need to share your details with Glenn because it sounds like or it looks like you've already done a lot of study. So please take note when I share your details with Glenn. Glenn, thank you for that comment. The other one that we need to get some view from you is from the council point of view. Are we ready? Is there political will to go to the fourth industrial revolution, as we said? Do we have the skills that are needed, and do we have a pipeline of skills? I know it wasn't part of your presentation, but we would like to know from PwC on some of your studies, are we ready as a country, and what impact is it going to have?
Thank you. Yes, if you look at where we are going with technology internationally and the fourth revolution with that, upskilling our workforce is extremely important. And that is one of the pillars that PwC look at, is to assist companies to upskilling their workforce. If you think of just what happened in the last year with COVID, I mean, we were forced to start to work, in a different way. So I think if you think of mining companies, this way of working has accelerated the acceptance of technology. So which helps in a bit, but we definitely have to focus on upskilling our workforce. That goes hand in hand as well with the acceptance and the adoption of the technology and the change that we set. People are afraid if they don't know something. So for us, I think in the studies that we've seen, it's one of the most important things that we have to focus today in our industry to get us ready for the next revolution. And we have seen it, and I think there's an openness and there's a willingness. However, we have not put in as much effort as we should have to get us to that next stage. I hope that answers the question.
Yes, thanks. It's almost like, yes, current situation is forcing us as a nation or the world to move in that direction. Okay, thank you very much, Chrisna. Marc, with COMOS having been implemented at several sites, we would like to get your insight. So you are now divorcing yourself from the design team within Anglo. We want you to represent the end users, the operators on site. What is the view of COMOS from the operations point of view? And have you seen it relating to any operation?
Sorry, you just broke up for that last bit of your question.
Okay, so the question is, from the operations point of view, are the guys seeing benefits as far as COMOS is concerned? But also, what is their view as far as COMOS is concerned?
Probably the site that's using it the most is obviously our base metal refinery, because that was the first implementation. Fortunately, they have the skills on site to maintain and update the database. I haven't heard any complaints, so I'm assuming it's going okay. What we are finding is, we need to do some customization or work around the workflows that are expected on site. So when you get a plant change notice, it obviously needs to go through several approvals. ASOPs need to be done, and that we want to automate within COMOS. We haven't gone all the way yet, but that's what we are looking at. Our other databases, I must admit, are still in the project phase and haven't been handed over to site. The one that we are planning to hand over to site is one of the Mogalakwena North, that we've just converted all the PNIDs and PFDs and network drawings to COMOS. The issue we found is that we used our AutoCAD drawings to convert, and our site wants us to do walkthroughs to make sure that what's in COMOS actually represents what is as built at Mogalakwena North Concentrator. But yes, yeah, we are entering that phase where we need to start handing over databases to the operations, and obviously that comes with some complexities and issues.
Okay. All right. No, thank you for that. There are a couple of other questions. However, due to the time, we are 2 hours and 5 minutes, 5 minutes over our planned time. So what we'll do is we'll distribute the questions that are not answered to the right people, and we can then resend the answers to the people that participated. And with that, I would like to thank everybody that participated in the session. I think it was a very informative, first of its kind. We have the speakers have. Also, I would like to thank the audience, the people that participated in the session as audience. There has been quite insightful engagement. But I also like to thank the team at FrequencyShift for organizing. It wasn't an easy thing to organize a session like this for the first time, that is, and also the support that we got from the different role players, such as EHL as well. Yes, I would like maybe just for the closing, just to get the last comments from the different audiences. So from the different presenters, Marc, just your concluding a few words. Then we'll go to Chrisna, and then we'll have the other speakers on stage, and then that will be our conclusion for the session.
Okay, yeah, no, thanks for the opportunity to present this. It actually gave me a chance to take a step back and look at, where we're heading with COMOS. Like you say, we still got a way to go, but I think we're making good progress. We've got quite a lot in the pipeline for the near future. So hopefully we'll accelerate the way we use COMOS and the benefit we realize from it. I'd like to thank everyone who posted questions as well. I see there are some questions directed directly at me, so I'll try and answer them before we close.
Okay, thank you for that, Marc. Just now, closing words.
And then from my side, I've posted my contact details in the chat. But I think, what we're experiencing is that, now is the time, to embark on all these journeys. I think the industry is ready for it. The industry has hunger for it. But one thing that we've seen is that they don't always understand where to go and what to do. So I think, if we work together and we can help the mining industry achieve greatness that they should with new technology. So that's from my side. Thanks.
Thank you, Chrisna, for your contribution. Ian, any closing words?
Theko, thank you to FrequencyShift for organizing this. I think it's fantastic that we as an industry are starting to talk amongst ourselves with all the different role players, from software developers through engineers, folk, Reimer, nice to see you, and all the way through to the end users. To get this tool to work, we actually need to look at the end users and the maintenance teams quite closely and see what we need to do as an engineering team to better enable the maintenance teams. And I think that conversation still needs to happen to an extent. But so well done, and thank you for organizing this.
Thank you. Thank you, Ian. Reimer, closing words?
Yes. Theko, thanks very much for the opportunity to be part of this. Was a really good experience, and I think what we have seen in the last year that there were many webinars over the product related to the COMOS product and XHQ. But I think I've learned actually today that we might even want to intensify that or repeat these webinars, because I think there is a lot of information in these webinars that is definitely interesting for people who are part of this. So thanks again.
Okay, thank you, Reimer. Frank, over to you in Germany. Last word.
Yeah, first of all, thank you really very, very much, Theko, for not only preparing that session, not only running that session, but all the efforts that you have taken together with your team. So pretty grateful to that and making COMOS a part of that, session. What I would like to add to Chrisna's comment, which I like pretty much, which was that the companies, the customers are interested in Industry 4.0 and even have hunger to go there. What I would like to send out as a message to all of you, yes, you can start your journey, no problem at all. And there is always someone there accompanying you, consulting you, giving you some recommendations from all the experience that we as Siemens, but also all together with all our partners, have already gained from former projects in other industries, in the same industries. So you can start your journey towards digitalization, and you are not alone. Thank you very much, Theko.
Thank you, Frank. I would like Fred on stage as well for the closing. Thank you, Fred. There you are. Closing words. We are actually closing the whole session. Closing words from you as our sponsor.
I am extremely excited with how today's session has gone. You know, I've been in this environment for some time. 15 years ago, I published something much in the line of where we wanted to go, ran a pilot project, and to see it getting to this stage and getting to a level of maturity and having this interaction, it reminds me of the PISA's beta group that we used to run way back. So it's fantastic. So as a senior citizen getting on now, it's actually nice to be part of this up and coming development. It's great. And I want to say to everybody, come on guys, let's do it. Let's push it and let's really see how far we can get with this integration.
Thank you, Fred. I think after that, there's not much to say other than, you know what, there is a lot of work ahead of us to make sure that we make this thing work. And as Ian has said, we need to look at the guys on site. And with that, thank you very much, everybody. It was an honor to be in your presence. It was an honor to have you representing your different roles, your different companies, and supporting the initiative that we have. The initiative is to make sure that we do the right things through COMOS, that is. Thank you very much. I would like to thank all our participants that supported the session, that stayed with us and that were commenting. We would like to thank you very much for your attending the session, and thank you very much, everybody. We shall see you soon. Thank you.